Here's another exponential equation for us to solve together, and it's very similar to one that's in your homework. So this time the base is e, and we have e to the 3x plus 2 equals 76. So here again, if it's not something where we can just express both sides as a power of the same base, which I'm looking at 76, I have no idea off the top of my head what power of e exactly that would be. So I'm not going to express both sides as a power of the same base. Then plan B is to take a logarithm of both sides. As I said in the last video, you can take any type of logarithm you want as long as you apply the same logarithm on both sides. Because the base here is e, it would be smart to use the logarithm base e, which is the natural log. So I'm going to take natural log of both sides of this equation. So natural log of e to the 3x plus 2 equals natural log of 76. Now there's a property, I think it's worth remembering, a specific rule that applies in this case, which is if you have ln of e to any power, let's say p, that's going to equal just the power p. And I can talk about why that is. So I can give you a couple of ways to think about that. One way to think about this is if you have ln of e to the p, there's a property of logs that says we can take this exponent and bring it down. So this is equal to p times natural log of e. And then keep in mind that natural log in general, that's log base e. So this is natural log of e is log base e of e. It's asking what power of e is e, and that's 1. So this right here is equal to 1, so this is p times 1, so this is just equal to p. There's a general rule with logarithms that if you have log base b and then an exponential expression base b, that these are inverse operations. Log base b, exponent base b, those are inverses of one another, and so it all just boils down to the power p. And then in this case, if it's ln of e to the p, well, again, that's log base e of e to the p, so that's just equal to p, according to that rule. That's the inverse property of logarithms. But that's an inverse property of logarithms. That's why that works. Okay, so that's a little explanation off to the side. But so, if I have ln of e to the 3x plus 2, because of this rule right here, the left-hand side is just equal to 3x plus 2. With logarithmic expressions like this ln of 76, it's best to leave it written that way. Don't put it into your calculator until the very end. Minimize your round-off error. So now we're just trying to get x by itself. So to get x by itself, first thing you should do is subtract 2 from both sides. So then I'll have 3x equals natural log of 76 minus 2. Just keep in mind that it's just the 76 that's inside of that logarithm. And then divide both sides by 3. So as far as an exact answer, you could give this for your exact answer. ln of 76 minus 2 divided by 3. If you input this into the calculator to get a decimal approximation, the way that I would input that, well, one thing I might do, I'll leave it alone, sorry. Let's just leave it the way it is. So we need to give parentheses to the calculator to tell it that this whole expression goes on top. So I would open a parentheses first, and then press that ln button on your calculator. When you press the ln button, for a lot of calculators, it automatically opens a parentheses. So watch out for that. You should put in 76 and then close that one up so that you're taking just natural log of 76. Then subtract 2 and close up the parentheses for your numerator, and then divide by 3. And so if you do that, you should get about I'm rounding this to 4 decimal places, but about 0.7769. And so that's the approximate value of x that satisfies this equation.